Hi everyone, today we're going to be looking at scientific notation. Scientific notation is used when dealing with very large or very small numbers. The two numbers you see here are written in standard notation and are really cumbersome to write with all of those zeros. Scientific notation gives us a shortcut. It makes our lives easier. So in order to do it, we take a number that is written in standard notation and rewrite it as a coefficient that is less than 10, but at least 1. As we can see here in our model, the coefficient is the number in the front. Notice it is less than 10, but greater than 1. Then we have a times 10, that 10 is our base, and a superscript 5, that is our exponent. It tells us how many times we're going to be moving our decimal, and if it's positive or negative, it'll tell us which way to go. All right, so using scientific notation, we have to look at that exponent. A positive exponent means the standard number is a large number, meaning it's 10 or more. Notice this example, that superscript, that exponent is positive. So for this number, it is greater than 10. A negative exponent means the standard number is less than 1. In this example, we have a superscript, an exponent of -4. That means this is a small number. So steps to converting to scientific notation. First, you need to locate the decimal point. Now, some numbers, there may not be a decimal point, and it's always assumed that if there's no decimal point, then after the last number, a decimal would be found there. Side note, a comma and a decimal are two completely different things. Don't mix that up. Next, move the decimal to a location that will give you a number between 1 and 10, or it could be the number 1 exactly. Write this new number down, followed by times 10, our base. We want to count how many times you had to move the decimal point, and use this number as your exponent, the superscript. Finally, we need to decide the sign of the exponent. A large number makes an exponent positive, and a small number makes an exponent negative. Let's complete the following two practice problems together. The first number is 3,500,000. We want to convert this to scientific notation. The first step says to locate the decimal point. There's no decimal in this number. It's understood that after the last zero, that is where we would find the decimal. Next, we're going to move the decimal to a location that will give you a number between 1 and 10, or 1 exactly. I want to place my decimal here, between the 3 and the 5. That means that will allow us to have only one number in front of the decimal, everything else behind. Next step says to rewrite that number, our coefficient, and add our base, times 10. Step 4, we're going to count how many times you had to move the decimal point and use this as our exponent. I had to move it 1, 2, 3, 4, 5, 6 times. And then we're going to determine the sign. A large number makes the exponent positive, and a small number makes the exponent negative. We can see that 3,500,000 is a large number, so our exponent will be positive. So there's our final answer. 3.5 times 10 to the 6th power. These two things mean the exact same number. Next, 0.000467. Step 1 says to locate the decimal point. We could see it's all the way over here to the left. We want to move it to a location that will give you a number between 1 and 10. Well, I can't put it all the way at the end because then the decimal, the numbers after the decimal, are greater than 10. If I put it in between the 6 and a 7, I still have a number greater than 10 in front of the decimal. If I move it to after the 4, well, that would give me a number less than 1 because those zeros are still there. So I'm going to place my decimal between the 4 and the 6. I have a number that's greater than 1, but less than 10 after. So let's rewrite that as our coefficient, 4.67. add times 10, our base, and then count how many times we had to move the decimal. We moved it 1, 2, 3, 4 times. Last step is to determine the sign of the exponent. A large number makes the exponent positive, a small number makes the exponent negative. This example, we have a very small number, so our exponent would become negative. There is our final answer, 4.67 times 10 to the negative 4. Now, we want to convert a number to standard notation, meaning we're going to take it out of scientific notation. Remember, a positive exponent means the standard number is a large number. It's 10 or more. In order to take the number out of scientific notation, we move the decimal to the right, however many times the exponent is. So for example, if the exponent is 8, we move the decimal 8 places to the right. A negative exponent means the standard number is less than 1. So to take it out of scientific notation, we move the decimal to the left, however many times the number is. So if I have an exponent of negative 4, I would move the decimal 4 times to the left. Now we're going to practice taking a number out of scientific notation and putting it into standard notation. The exponent tells us how many times I need to move the decimal and if I'm moving the decimal to the left or the right. Remember, a positive exponent means I'm going to be moving my decimal to the right. I want to add zeros after the final number in my coefficient. For this example, I have a positive 8, so I need to move the decimal 8 times. Start by writing your coefficient again. Since we know that we have to move it to the right, I give myself a little room to move my decimal. I'm moving it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. My decimal would be there all the way at the end. Now in each of these waves, I need to add a 0 as a placeholder. It's not a number greater than 0, otherwise it would be existing in our coefficient. Remember, when we wrote it in scientific notation, we didn't care about all those zeros after the last number in the coefficient. Well, now we need to bring them back. So our answer in standard notation is 617 zeros. Next practice, 8.6 times 10 to the negative 3. Our exponent is negative. That means we need to move our decimal to the left in order to take it out of scientific notation. A negative exponent tells me that I have a small number. So I'm going to give myself a little bit of room to work because I need to add my zeros before the 8. I'm moving it 3 times. 1, 2, 3. In each of those waves, I add a 0 placeholder. So there's my final answer, 0.0086. Pause the video now to complete the following 4 checkpoint questions. Once you believe you have your answers correct, resume the video to see the answers. First problem, we need to convert to scientific notation. Step 1, find the decimal. It's here all the way over to the left. We then move the decimal so that there's only one number in front of the decimal place. We remove it here between the 5 and the 6. Rewrite that number as your coefficient, add times 10. You then need to count how many times you moved the decimal, 1, 2, 3, 4, 5, and make that our exponent. Finally, determine the sign of the exponent. A large number makes a positive exponent. A small number gives you a negative exponent. You can see that this is a very small number, so our exponent would be negative. Our answer is 5.67 times 10 to the negative 5. Next checkpoint question. We have to convert this to scientific notation. Step 1, find the decimal. It's not easily identifiable. It is assumed it is after the final 0. Move your decimal so that there's only one number in front of it. I would move it here in between the 1 and the 0. Rewrite this number to 1.067. I care about this 0 because there are numbers after it. All of these zeros, I can leave them. Add times 10. Count how many times you move the decimal. 1, 2, 3, 4, 5, 6, 7, 8. Next, determine if it is positive or negative. A positive number is a large number. A positive exponent is a large number. A negative exponent is a small number. This is a very large number, so it stays positive. Our final answer is 1.067 times 10 to the 8. Final 2 checkpoint questions we have to turn into standard notation. I have a negative exponent that tells me I need to move my decimal to the left. I'll give myself some room to work, 4.47. I'm moving it to the left, making it a small number 5 times. 1, 2, 3, 4, 5. In all of those waves, I add 0 placeholders. So my answer is 0.0000447. Final problem, 6.31 times 10 to the 3. I have a positive exponent, so that means I'm moving the decimal to the right. I'm making the number large. So I'll make sure to give myself some room to work. I'm moving it 3 times. 1, 2, 3. In that lull, we'll add a 0 placeholder. So our answer is 6,310. Being able to convert a number into and out of scientific notation is a great skill to have. However, sometimes you're going to have to perform calculations using numbers in scientific notation. The easiest way to do this is to use your calculator, but we want to replace the times 10 part of the number with the E, EE, or EXP button. Note, on most calculators, you're going to have to hit the second button in order to use the E, EE, or EXP button. Let's do this practice problem together. So take out your calculator now. For this practice problem, we have 3.41 times 10 to the 12th power multiplied by 5.25 times 10 to the negative 2 power. When performing this calculation using our calculator, we want to replace the times 10 in our scientific notation number with E or capital EE or EXP. I'm using a TI-84 Plus. You'll notice on the TI-84 Plus there is a green E, but then there's this blue double E. We want to use the blue double E, the one that's above the comma button. That's the engineering exponent button. In order to use the engineering exponent button, I need to hit second. So let's plug this into my calculator to perform the operation. 3.41 second, comma. Notice how I get a capital E. You don't need to do times E, E caret, E times 10. That's just wasting time. That capital E that's displayed on your screen in your calculator, it knows that you mean times 10. So you simply type in the exponent after. No caret 12, no times 12, none of that. First of all, it's going to totally mess up your calculation. You're probably going to get an error button. Second of all, why waste time pressing buttons that you don't need? Work smarter, not harder. We're multiplying these two numbers, so our multiplication button. 5.25, here's our times 10, so second comma, so I can get my E. My exponent's in negative 2, so don't forget you have your negative button, 2, hit enter. 2 decimal places will work just fine. So we could see in our calculator we have 1.79 E11. That's great, but it's not proper scientific notation. So we need to change the E in our answer back to times 10. So our answer is 1.79 times 10, because that's what E means, 11. Calculate the following using your calculator. Answer in scientific notation. Pause the video now to complete the calculations, then resume to see your answers. 1.4 times 10 to the 6th multiplied by 2.5 times 10 to the 3rd power is equal to 3.5 times 10 to the 9. 3.6 times 10 to the negative 4 divided by 6 times 10 to the 3rd power equals 6 times 10 to the negative 8. If you did not get these answers, please try typing them again in your calculator until you feel comfortable with replacing times 10 with the E or capital EE button.